In today's lesson, we will be solving radical equations. In other words, equations with square roots. And here are the steps. Number 1, isolate the radical. That just means get the square root by itself on one side of the equal sign. And then you're going to do the inverse operation of the square root, and that is to square both sides. And then after you do that, you can just solve for x. But if you happen to get a quadratic at any point, we will solve by factoring. And then the last thing, you have to check for extraneous solutions, or what I like to call fake-out solutions. Sometimes when you're solving radical equations, using these steps you'll get a solution, but then when you do the check step, it actually turns out it's not a real solution. So you are actually required to check every single solution, because some of them are fake-out ones, and if you don't check it, then you might get it wrong. So here's the first example, the square root of x minus 3 equals 4. We first want to isolate the radical, so we want that square root by itself, so we have to get rid of this minus 3. So let's add 3 to both sides. So the square root of x equals 7. And now, inverse operation of square root, we're going to square both sides just to simply cancel out the radical sign. So x equals 7 squared is 49. So there's our solution. Let's do a quick check by plugging it back in here. The square root of 49 minus 3 equals 4. So 7 minus 3 equals 4. It works. So that's our solution. Here's our next example. The square root of x minus 3 equals 4. So the first step is to isolate the radical, but actually the radical is already by itself on one side of the equal sign. So we can go ahead and square both sides. So when you square this, the left side, it just cancels out the radical and leaves you with x minus 3. And then we can square the right side, where 4 squared is 16. And then all we have to do, add 3 to both sides. So x equals 19. And then check for extraneous solutions. Just plug that back in real quick. The square root of 19 minus 3 equals 4. 19 minus 3 is 16, and the square root of 16 equals 4. So this one also works. Okay, next example, the square root of 2x plus 6 equals 4. Step 1, we have to isolate the radical, so that plus 6 needs to be moved to the other side. So let's subtract 6 and subtract 6, which leaves us with the square root of 2x equals negative 2. Now, we need to square both sides. And when you square the radical, cancels out, leaves you with 2x equals negative 2 squared is 4. And then divide everything by 2. So x equals 2. Now let's check for extraneous solutions. So when you plug it back in, let's look at the square root of 2 times 2 plus 6 equals 4. So 2 times 2 is 4. The square root of 4 plus 6 equals 4, which this doesn't make sense because 2 plus 6 does not equal 4. So in this case, 2 is extraneous, which means there is no real solution to this problem. And if you back up a couple steps, you should be able to see why, and that would be right here. You can never take the square root of a number and have it equal a negative number. So you could have even realized that further back. Okay, moving on with more examples. I'm giving a lot of examples in this lesson just because with radical equations there's a pretty big variation of ways to solve them. So let's do this one. Isolate the radical is the first step, and it is already isolated. So let's move on to squaring both sides. Square the right side to cancel out the square root, and then square the left side. So now we have x squared equals x plus 6. So now we want to solve for x. But this is where factoring comes into play, because we have a quadratic and we have to solve by factoring. So this goes back to the last unit. Remember, when we want to solve by factoring, you first have to set your equation equal to 0. So I have x squared. I'm going to bring x to the left side by subtracting, and I'm going to bring 6 to the left side by subtracting. So it's equal to 0. Now I need to factor that trinomial. So I need factors of -6 that add up to -1. Well, I know that -3 times 2 equals -6, and -3 plus 2 is -1. So factoring this, I'll have x minus 3 and x plus 2 equal to 0, and then use the zero product property to finish solving. What value of x right here would set this equal to 0? It's the opposite, so x equals a positive 3. And then this binomial, what value of x would allow this equation to be equal to 0? Opposite of positive 2, it would be -2. So those are my two solutions. However, we still have to check for extraneous solutions. And these extraneous solutions seem to pop up more when we have a quadratic. So, for the first one, let's plug in 3. 3 squared equals the square root of 3 plus 6. 3 plus 6 is 9, so let's see, 3 squared is 9. Sorry, I just realized I made a mistake. That squared is not part of the original problem. So, plug in 3. 3 equals the square root of 3 plus 6. So 3 equals the square root of 9, and the square root of 9 is 3. So 3 is definitely a solution. Now let's check if -2 is a solution. Well, if we have -2 equal to the square root of -2 plus 6, -2 equals the square root of 4, and the square root of 4 is 2, and -2 does not equal a positive 2. So in this case, -2 is an extraneous solution, and 3 is our only solution. Now we have the square root of x plus 5 equals 2x. We first have to isolate the radical, but it's already done. So now we can square both sides. So on the left side, we're left with just x plus 5. But on the right side, when you square 2x, make sure you square both terms, or both parts of the term. So 2 squared is 4, and then 4x squared. Now we have a quadratic, so we have to solve by factoring, which means we have to set it equal to 0. When you're doing this, always try to keep the front number, the leading coefficient, positive. So I would never subtract -4 over. Instead, I'm going to move my x and my 5 to the right side. So 0 equals 4x squared minus x minus 5. And now we want to factor this. Because there's a leading coefficient, you can factor using guess and check or using the AC method. So here are the steps using the AC method. If you prefer guess and check, you can go ahead and ignore those steps. But if you prefer AC method, you can go ahead and just pause the video, walk through the steps, and make sure you understand them. But moving on, up to the right, I now have that quadratic in factored form, and now I'm going to solve it using the zero product property. So I'm going to break up my two binomials. I first have 4x minus 5. You set each of them equal to 0 and solve for x. And x plus 1 equals 0. So this left one I have to add 5. So 4x equals 5, and then divide by 4. X equals 5/4. And then on the right side, x equals -1. So those are my two solutions. But I now have to check for extraneous solutions. So now I need to plug them both in. So I have the square root of 1.25 plus 5 equals to 2 times 1.25. So the square root of 6.25 equals 2.5, and when you take the square root of 6.25, that is true. So here's one of my solutions. Let's check to see if this other one works. So the square root of -1 plus 5 equals 2 times -1. So that would be the square root of 4 equals -2, but that's not true because the square root of 4 equals a positive 2. So -1 is an extraneous solution, but 5/4 is a solution. Here's one last example of this type that if you'd like to try on your own, you can. So go ahead, write this down, and pause the video and see if you can do it on your own. Did you get it right? Now here's the last type of equation you might have, and that's when you have square roots on both sides of your equation. So they start out looking a little bit more complicated, but they're actually the easier ones to solve. Because your very first step can be to simply square both sides, because you will cancel out the radical sign. And now you're just left with 3n minus 2 equals n plus 6. And now you can simply just solve for your variable. So we have to get our n's onto one side. So I can subtract n and subtract n. So 2n minus 2 equals 6. Add 2 to both sides. So 2n equals 8. Divide both sides by 2. So n equals 4. And then you can do a quick check. When you plug in 4, you get 10. And then when you plug in 4 here, you get 10. So the square root of 10 should be equal to the square root of 10. So it works. Here are the last two examples of the lesson. So if you want, go ahead and write them down, pause the video, and try them on your own. For the first one, you should get x equals 5, and for the second one, you should get x equals 4.5. And if you plug them both in, they should both work. So there's the lesson. Good luck and have fun.